So this class is mostly going to focus on the HP Store virtual line of SAN products, which is pretty much primarily what ICCS deploys at customer sites. But I still think it makes sense for us to review, or go over a short history of SAN, what SAN is, what the architecture is, and some of the components of the SAN infrastructure. So what is SAN? SAN stands for Storage Area Network. Basically what a SAN is it allows you to take various different servers which have hard drives, storage, and put them together in connect them in a network to allow you access to all of the storage and all of the SANs as one big pool of storage. And then with that one big pool of storage, you're able to logically carve out drives that you can then present to other servers that you're using to run operating systems and applications to be able to access that storage and store files and folders and databases on those logical volumes. So the SAN architecture, SAN was pretty much created around 20 to 25 years ago, approximately. Initially, when SAN came out, it was something that pretty much mostly Fortune 500 companies were interested in because the architecture at the time, the networking architecture that's used to connect all SANs when it was first created is something called Fiber Channel. Fiber Channel is a networking architecture that basically requires specialized equipment all across the board. You need specialized switches, specialized cables to connect each of those server storage units, and because everything was specialized, it became very expensive to deploy. So pretty much only very large companies that had the funds to be able to afford such such a architecture like that, they were able to take advantage of what SAN has to offer. And speaking of why would someone want to use a SAN versus any other storage? So I mean, typically, as we know historically, most storage has been directly attached to whatever server you want to you want to run an application on. You would purchase a server, purchase storage just for that server alone, and you were locked in with that server to be able to only access whatever hard drives were in that actual server itself. No other server could take advantage of storage in that server. So if you had a lot of free space in one server and no free space on another server, there's no way for the server that has no free space to be able to access the storage on the other server that has a lot of free space. So SAN allows you to basically separate the storage from servers that are actually running applications, and it allows you to be able to create volumes which you can then present to any different amount of servers that you want to connect to the SAN, and you can dynamically change the sizes of volumes and allocate to whichever server needs more free space, because you're able to control the size of those volumes, and you can easily expand volumes that are on the SAN.
So multiple servers can access a single storage.
Exactly. They can all access the single SAN and be able to access any number of volumes that are on that SAN. And typically, SAN runs a specialized form of operating system. HP Store Virtual runs the SAN software called SAN-IQ, and it was originally created by a company called Left Hand Networks. HP bought them around 2008 or so, 2009, and then they renamed it a couple of times. It became HP P4000, and now it's HP Store Virtual. There are other SAN operating systems out there. There are plenty of them. There's Equalogic, made by Dell. EMC has a number of them. There's many different storage vendors out there have their own versions of SAN operating systems to run their units. So getting back to architecture, So we mentioned that the original architecture that was created for the purpose of connecting SAN units was something called Fiber Channel. And like I mentioned, Fiber Channel was extremely expensive because it required a lot of specialized equipment in order to connect SAN units. Then came a protocol called iSCSI. I basically stands for Internet. SCSI is, as we know, is a way of connecting hard drives to servers. And basically, the iSCSI allowed for connecting SAN nodes using a protocol that we're all very familiar with, TCP/IP. Basically, you didn't have to purchase specialized switches or specialized cables anymore. You could use the same switches and cables that we use to connect devices to create a local area network or to create a wide area network. That this allowed for being able to connect SAN storage units together using everyday networking equipment. So that obviously brought the cost of SAN down tremendously, and as such, these companies like Left Hand Networks and Equalogic, which used to also be owned a separate company on its own that Dell purchased. These companies were able to bring down the cost of SAN to basically our type of size clients, which is known as the SMB market, small, medium-sized businesses that aren't large enterprises, and that allowed those small, medium-sized businesses to take advantage of what SAN has to offer for storage. So, just to review some of the components of the SAN infrastructure. We have SAN nodes, so those are the actual units themselves that are running the SAN operating system. They typically look like regular servers, but they're running a specialized operating system, and they of course have a lot of hard drives in them. And then those SAN nodes are connected via specialized, well, they're not actually specialized, but they're dedicated. I think that's a better word to use. They're dedicated switches. So it's pretty much, we purchase Ethernet switches that we use that are dedicated only for SAN traffic. We don't want any other, LAN. We don't want to mix any other networking that happens in a network on the SAN switch. We want to have it dedicated totally to SAN traffic. And then finally, we have a management server because of the fact that the switches are dedicated for SAN only. We keep the SAN network on a completely separate network that really isn't accessible at all from the regular LAN. We need a computer or a server that is able to run the management software, which we'll get more into shortly. But that computer has to be able to have a second NIC in it, which then plugs into the SAN switches. And then it allows you to use TCP/IP, regular IP addressing, to access all the different components of the SAN. Physical, virtual versus virtual. So typically, historically, all SAN nodes have been physical. Basically, what that means is it's a dedicated server with hard drives that only runs the operating system for the SAN and nothing else. It's completely dedicated to that purpose, and in many high capacity requirements of various clients, they do require to have a physical dedicated SAN, just to keep up with the demand of what is utilizing that storage. Such as, let's say, Oracle databases or high use SQL databases. But there's also a concept called virtual SAN. Virtual SAN is basically the SAN operating system that's not running physically on the server. Rather, you're running some other hypervisor on the server, either VMware or Hyper-V. ICCS typically uses VMware. The hypervisor is installed physically on the server, usually on a USB flash drive, and then that server boots up VMware, and then at that point, you have a data store that's created on the local storage of that server. And on top of that data store, you can have a virtual machine that's running the SAN-IQ or whatever other SAN operating system, and that will take advantage of all of the storage in that data store. So typically, if let's say you would purchase a server that has 10 terabytes of storage, you would basically create a data store that's using most of that storage. We like to leave maybe about 100 gigs or so just as a buffer space, just in case sometimes when you upgrade the virtual SAN, you need a little bit of extra space, or if there's anything that we want to put out of the virtual SAN, we would install it, in that buffer zone. But typically, the data store would the capacity would be most of the capacity of what that server is, and then we would then install the virtual SAN, virtual machine, and utilize that capacity, and then when we do that on a secondary unit, we're able to connect the two the same way we connect physical SANs. We would still use a switch, a dedicated switch, and the servers obviously would have NICs that are dedicated only for the SAN network, and then the SAN software allows us to choose which NICs we're going to dedicate to run the SAN software. And then at that point, that server could serve a dual role of running virtual machines, whether it's a domain controller, file server, on top of the SAN-IQ software. So in other words, you're able to connect to that same, on the same machine, you're able to connect to the storage, but you have the layer of the virtual SAN in between, so that you're still able to have the benefits of a SAN where you can pull together multiple storage units and then carve out from that pool of storage volumes that the virtual machines will run on. So basically, you have the storage, you have a server running both the SAN software and also virtual machines. So that type of setup for virtual SAN will work for smaller environments, because obviously you have a lot more demand being put on those machines, because they have to run also the storage software in addition to any of the other virtual machines that you plan to put on there. So those are fine for lower demand applications, but if you have a very large network, then you're going to have to look at getting physical SANs to be able to handle those needs.
So this is a way to use the internal storage of the hosts
Exactly.
as SAN
as
shared
SAN
and
SAN.
redundant between the hosts.
Exactly. Correct. So methods of connectivity to volumes. So basically, once we have our either physical or virtual SAN set up, the way that we connect to those volumes once we create volumes is through the protocol which we mentioned before, called iSCSI. So pretty much most operating systems, whether it's Windows, Linux, even VMware, has a iSCSI software initiator, which is basically a driver and a little piece of software that allows those operating systems to connect to volumes that you create on the SAN. We're going to go through that a little later on when we show demonstrations of how to connect to a volume. But just wanted, as an overview, to mention that basically iSCSI is the method that each operating system is able to connect to the storage system to be able to access that storage.
Are we connecting the ESXi hosts or the Windows virtual machine?
So it depends. Initially, if you're doing virtual SAN, then you have to use the ESXi host to be able to connect first to the to the SAN nodes to be able to access storage on there.
So you configure the ESXi with iSCSI to connect to the
Correct.
virtual.
Correct. And then in addition to that, your Windows guests, also every Windows machine has, from 2003 and up. Actually 2003 you actually have to install it, it's a separate install, but hopefully we don't have to deal with any 2003 machines in the future, but everything from 2008 on up has the iSCSI initiator built in. And as long as you are able to access that SAN network, which can be done by adding another NIC to the virtual machine that's dedicated for the SAN network, which we'll show you examples of. So once you have that NIC configured for that SAN network, then you're able to access those volumes that are on there.
But is it something we do, or we only do either or?
No, we will do both. We will do both,
Both.
and you will see how it goes.
So if it's physical, you don't need to go, Windows can connect directly to.
Well. The issue is that most servers that we create these days are virtual.
Right.
Gone are the days where we used to create physical servers, because of virtualization allows us to pull together multiple virtual servers on one physical server. So basically, you're going to first connect the physical machine, the ESXi, to the SAN network, so that it's able to address the SAN network. And then once that's connected, that allows you to take the virtual machines that are inside ESXi, and you're able to point them to the SAN network from within ESXi.
You do not need the iSCSI inside the virtual machine.
Oh, you do.
Oh, still
You still do. Yes, but they still because you're running a hypervisor. You still have to go through the hypervisor in order to access networking. Every device, whether you're plugging a USB stick, whether you're trying to add a NIC, whether you're trying to add another virtual hard drive, everything has to be connected through ESXi. You're still going through that layer,
So
which you'll see once.
in the hypervisor, you add the data store, and then within the guest OS, you connect to the iSCSI.
Yes, correct.
Not using the hypervisor to provide storage to the guest VMs. You still install iSCSI inside the guest VM to directly go to the SAN.
Yes, and it's connected with something called iSCSI multipathing, which is a separate topic. But basically, that allows you to utilize multiple NICs in ESXi, and it actually load balances between the two. And virtual machines go through that. It kind of creates like a highway into the SAN network through ESXi, and then accesses the storage there on that network.
I don't know if it's within the scope of this, but I just had a question about LUNs versus block storage. Is that within this?
Yeah.
or-
So that's actually that's a separate.
Okay.
Yeah, it's a separate topic. Okay. So SAN management using the CMC. So basically, like we mentioned before, one of the components of the SAN infrastructure is that you need a physical management computer, whether it runs a server OS, it can even run a client OS. The purpose of that management server is to run the software that an administrator would use to control and to configure the SAN. So in HP's case, they have a management console called the Centralized Management Console. It's abbreviated CMC, and that's actually what we have in our screen right up over here. This is a view of the CMC, and it's a Java-based application that you download from HP. You install it, and then it allows you to access the SAN nodes and then configure it from there. SAN, so I just want to veer off for a little bit just to discuss something very important, the SAN planning worksheet, which I will bring up on the screen here. So the SAN planning worksheet basically is a very helpful worksheet that has a lot of information on one page, so that you can easily architect a new SAN infrastructure. And in addition to that, once it's architected, allows you to administrate it in the future by being able to see all information at a glance about each of the various different SAN units and hosts that you have at the particular implementation that you're doing. So it's very important to, before building a new SAN setup, to first work on creating a SAN planning worksheet, so that you can itemize the various components of the SAN. So in this case, for example, this is an example that I pulled up from GNA, where we have a SAN switch, 2 SAN switches, and in addition to that, this particular setup has 4 SAN clusters, and you can see at a glance what their IP addresses are and what their ILO IP addresses are. In addition to that, we have our designated management PC.
So the cluster isn't.
Yeah, we're going to get to what a cluster is shortly. But basically, this SAN spreadsheet just allows you to put together a list of all the components of the SAN implementation that you're doing, and more importantly, allows you to allocate IP addresses, because one important thing of the SAN network that we mentioned already that it's dedicated, and another important thing to remember is there's no DHCP running on the SAN network. It's completely statically assigned. So that's why you always have to make sure whatever IP addresses you assign to components in the SAN network, that they do not conflict with anything else. That's one of the big benefits of having the SAN planning worksheet, is it allows you to check at a glance to see if any particular IP addresses are being used, and therefore you won't use it when you're trying to assign devices or servers, for that matter, to the SAN network. Because as we see over here, every SAN unit has its own dedicated IP address on the SAN network. Every host has an interface as well on the SAN network so that it can communicate, so it has an IP address on the SAN network. In addition to that, towards the bottom, you'll see each of the virtual machines that are running. Some of them have SAN IPs because they access SAN storage directly through the iSCSI initiator inside Windows. So if you're going to use the iSCSI initiator inside Windows, you need to have a dedicated NIC for that. It's a virtual NIC, but you need to have a dedicated NIC running on that network, and it has to have an IP address also.
Is it faster that way, or what is the reason of doing that?
So that's a good question. So typically, in our original training, Ike and I took back in the day when they initially released Left Hand, or when HP bought Left Hand, they basically advocated for Windows machines to connect to SAN storage for additional volumes using the in-guest iSCSI initiator. There is another way that you can connect using something called RDM, which stands for Raw Device Mapping. And that goes back to your original question of, is the ESXi server connecting, or is, how do we access the storage with virtual machines? So there is a way to access it via the ESXi, which is something called RDM, Raw Device Mappings, which we did set up at 1 or 2 clients. However, there are issues with RDMs when it comes to snapshots, VMware snapshots. There are some drawbacks to it, and initially we did think that performance was better, or it was more increased when using RDMs, but further testing proved that the performance differences are not really so great, and you basically have a lot less issues with other types of things, such as if you wanted to do site recovery management. You have less issues when using in-guest iSCSI initiators than you do with using RDM. So as a matter of protocol, ICCS typically sets up servers that have their additional drives This is not for the C drives, which is something we're going to get to later, but basically, typically what we do is for C drives of servers, those are all contained within a dedicated SAN volume that's used just for VMDK C drives. The question is that comes up is when you have additional drives, how do we connect those additional drives to servers? So one third method is you can just continue to create VMDKs,
The simplest.
yeah, and we do that. For example, if we're P2Ving a server, then we usually you don't have a choice at that point. You have to convert the physical server and all its drives into separate VMDK files. Initially, HP wanted you to connect additional volumes using iSCSI Initiator. They didn't advocate connecting via VMDKs. It seems like they changed their tune lately, and they seem to think that you won't have any performance losses using VMDK, and the ESXi as it matured, over the different versions, did increase their performance, where you could actually run high performance databases such as Oracle and SQL directly on VMDKs and not have it connect to the SAN storage directly. However, as a matter of protocol, we've continued to connect all of our additional drives directly using the iSCSI Initiator, and it's just to keep things a little bit simpler, and also in line with our previous setups that were done in that way. Which we'll get to exactly how to do all that. At this point, we're just overviewing exactly everything we how we set things up from a farthest view. Okay, so the next item to discuss is basically SAN node configurations. So typically, when you crack open a box, brand new SAN node, you put it on the rack. Or truth is, even before putting it on the rack, if you're prepping it at ICCS, is like you're doing right now, but you're actually doing it with a virtual SAN, which is similar, but there are some differences. Obviously, physical SAN, when you open it up and you connect the monitor and you boot it up, you'll notice after the post screen, it will start loading the SAN IQ operating system. And then
it comes preloaded from.
Exactly, it comes preloaded from HP, and
Because this is bought, you buy it as a
exactly.
SAN.
When you buy a SAN node, which usually they come in kits, kits of two. You typically don't just buy a SAN with one node. It kind of defeats the purpose. The SAN IQ software is meant to run with at least two nodes. So typically you buy a kit that includes two SAN nodes, and it does come pre-installed, and when you boot it up, you will see the SAN IQ software loading, and then you typically get to a very text-based dumb screen that basically allows you to do very little. To pretty much just configure an IP address. That's about it. So basically, after when you are planning and architecting a new SAN infrastructure, and you have all your IP addresses mapped out, once you crack open a box and you start taking SAN nodes out to configure them, basically all you're going to do on the console of those SAN nodes is pretty much configure the IP address, and that's about it. At that point, once you connect the SAN node, its NICs to the SAN switches, you're going to be switching over to using the CMC to further manage that SAN node and join it together with a pool of other SAN nodes. The other important thing to configure is, of course, ILO. ILO stands for Integrated Lights Out. ILO is a technology found on all HP servers that allow you to access the hardware directly on the server, being able to see everything from status, what's going on the console of the server, and being able to remotely power up, power down, reset, a lot of the functionality that you can do if you were physically in front of the box. So that helps very much in troubleshooting things. SAN nodes are typically very stable, but nothing's perfect, as we all know. So there are times when we have to troubleshoot, outside of the SAN IQ, because we can't reach it through the CMC if the node is not pingable. So ILO helps in being able to do that remotely without having to physically be there. Disk RAID levels. Typically, the SAN units come pre-configured with the disk RAID level. So usually most of the units we purchase come with a RAID 5. Some very larger units come with a RAID 6 because a RAID 5 would take a very long time to rebuild if one of the drives should fail. So you might find a case with 3 terabyte drives, a SAN node with 3 terabyte or even 4 terabyte drives. Those units are probably going to have a RAID 6. You do lose a lot of storage because you have the extra parity, but typically, that's when you're required for such high capacity SAN nodes. So you usually don't have to change the network RAID. They come pre-configured. And then we have the networking configuration, which basically, so that's done. That's the only part you're going to actually do is the IP address itself. Later on, once we get into the CMC, we will see that you're able to configure a couple other items in the networking section, and two of the most important concepts are bonding and jumbo frames. Bonding basically allows for being able to use redundant switches. The best practice that HP wants you to use for bonding, which is something we will see, but just to show you. Typically, bonding is something that when you would bond 2 ports on 2 servers, you would have to also bond them also on the switch. There is a type A of bonding which is called ALB, adaptive load balancing, which basically allows for you to not have to do that, and it allows for you to be able to connect 2 NICs on the node, on the physical node, to 2 separate switches, because you can only bond ports that are on the same switch. So if we want to have redundant switches, how are we going to be able to accomplish that with bonding? Because bonding typically requires that you only do it on 1 switch. So this technology called ALB, adaptive load balancing, allows us to choose, allows us to plug our SAN NICs into 2 separate switches, and it will load balance between those switches. So, for example, just as an administrative example, if let's say all your SAN nodes are connected, each NIC to 2 separate switches, and you want to be able to, let's say, reboot one of those switches, you actually can do so without bringing the entire SAN down. So that's one big benefit of using ALB, which, as you see over here, just to show you, we'll get into more exactly what all these items are, but just to look at the individual storage units themselves on the screen, we see that there is a section here called network, and here's where we can see our bonds. So in this particular case, we have a bond between 2 NICs that's using, as it says over here, balance ALB, which stands for adaptive load balancing. So that's something that we would do, that we would configure whenever setting up a new node. We would originally, you would see over here the 2 NICs individually, and basically you could configure the IP address on one of the NICs. And then you would right-click and choose New Bond, and then that would allow you to then select those 2 NICs, and then choose what type of bond you want, and then the bonding that we would use is called ALB, adaptive load balancing, and that would create what we see in front of us right now, where we have basically both of these NICs that are bonded together, and they all share the IP address of 192.168.9.90. in this particular case.
And if you only have one switch, you still can.
Yeah, you can still. It's still a good idea to create a bond. It'll still work even with just one NIC plugged in, and it will allow you to utilize that other NIC when you do have another switch.
Does it combine the bandwidth?
It does not in the same way that if you would use regular 802.131 AD bonding, but it does increase it. It does increase it somewhat. It's not the full capacity, but it does provide a little bit more bandwidth than typical
Is it
one.
to use if you only have one switch?
It is because you might get another switch, and then
Plus,
it's
you can
easier.
have an
It's
issue
easier
with the
to.
cable. That cable you still have it.
Exactly. It allows, in other words, even if you just have one switch, you can plug both of them in
Right.
to that same switch, and then it'll provide a level of redundancy between the NICs on the server and also the NIC ports on the switches themselves. Another concept in network configuration of SAN is the concept of jumbo frames. Jumbo frames refers to the size of the frame that this is going back to networking basics over here in the layer 2. The typical frame size that pretty much everyone has standardized on is 1500 MTU, which is basically most networks operate. Most local area networks, and a lot of WANs as well, operate with a frame size of 1500. It's something we just about never change, so that we can provide full compatibility with whatever other networking devices that we are connecting to. With SAN, there is a benefit or considering changing the frame size to the maximum. Of 9,000 MTU, which is known as a jumbo frame. And basically what that does is it allows you to fit a lot more data in one frame. And the thinking goes is that because you have a dedicated network of SAN nodes that are only talking to each other, they're not talking to anybody else, you might gain some performance with increasing the frame size to the maximum, being able to fit more data in a packet. Originally, we did configure a lot of our early SANs with jumbo frames, and it's something you actually have to enable on every device in that network. So basically, you have to enable it on the switch. You have to go into the configuration of the switches and tell it that it should allow for jumbo frames. You have to make sure that the MTU setting on every node is set to 9,000, as it is over here at GNA. You can see over here.
Is it
says
exactly
frame size
9,000, or sometimes
Yes.
it's a more special number?
No, it's 9,000. That's actually the maximum. There are numbers in between that you could use, but the largest is 9,000, which is what's supported with pretty much any other networking device. And in addition to that, you have to make sure whatever NIC that you connect, whether it's a physical NIC on ESXi, or a virtual NIC inside Windows that's using the iSCSI initiator, you actually have to change the configuration. And I can show you on this management computer at GNA, you have to actually go into the properties of the NIC. It's really in the driver section. And when you go to the properties of the NIC and you click on configure, and then you go to the advanced section, you'll see that there is a setting called jumbo packet. Okay, so as I was mentioning with jumbo frames, our original deployments that we did, probably I would say the first 5 or 6, we did configure jumbo frames across the SAN network. And then upon further testing, we discovered that it really didn't provide much of a major benefit for the applications that we were performing. So We definitely stopped doing it for some of the smaller ones that we've been deploying, and just kept it simple, as I was explaining to Jeff. There are some issues when using larger frames, and as you have to make sure every little thing is compatible that you plug into the network. We had one particular situation where we had to stretch the SAN network across a LAN to another location so that we can provide some redundancy with remote copy, which is another one of the features of the SAN IQ, is it allows you to provide a DR a site, with a snapshot of every single one of the volumes that you have, so that in the event something happens in the primary location, your data is still safe at the disaster site. So it was a big deal to get the WAN provider to support jumbo frames. So when you do little things out of the ordinary, sometimes you run into issues. So you sometimes have to weigh the benefits of doing so versus what you're going to gain out of it.
So the standard is.
So the standard, we leave it at 1500 which is it's the default setting, and it's nothing really have to change. But you should be aware if you're ever troubleshooting or administrating existing deployments that we have, to make sure that you're to find out first, are you dealing with a SAN network that's jumbo frames enabled, meaning 9000, or not. And the best way to do that is you can just go into the CMC, look at any node, click on the network, and you'll see right away whether or not you're dealing with a frame size of 9000 or not. And as I was showing before, also, if we look, this particular management computer has a NIC that's connected to the SAN network. If you go to the properties of that NIC, okay, and then click on configure, and then look at the driver properties under advanced, you'll see one of the features is jumbo packet, and as you can see, it is enabled with the jumbo frames of 9000. So basically, your choices are something in between, or totally disabled, which will give you the default of 1500. Okay, moving forward, one other important thing when setting up new SAN nodes is licensing. Licensing basically has to be done using an order number that you receive. When you purchase the HP SAN, it comes with a packet that has a particular order number that has to be registered on HP site. All of our SAN order numbers are registered with Morris's credentials, which is Morris at ictslc.com for the username, and then the password we'll give you, that will allow you to register the order number, and then it will ask you for the MAC address of the SAN node that you're trying to register. So if you look on the CMC, basically every single, even if you click on the node itself, you will see on the main page of the node what the MAC address is, which is this over here. Unfortunately, you can't copy and paste, so you actually have to type it in on the website. So basically, it'll ask you for the order number, you'll enter the order number, and then it'll ask you for the MAC address that you want to register that order number to. And then at that point, it will register this particular MAC address, and then it will provide you with a key to use for registering and licensing the SAN. And there's a tab here called Feature Registration, which allows you to type in this extremely long product key. So basically, you would click on Feature Registration Tasks, Edit License Key, and then you would copy and paste the license key in here that you received from HP, and then at that point, all the features here will say licensed. Before that, if you haven't licensed yet, you do get I think it's 120 days, or maybe between 60 and 120 days of full use of the node before it starts giving you problems. So you have a little time, but if you don't do it right away, you forget, and then it's always better to make sure you get your licensing in place, because the last thing we need is a newly deployed SAN to go offline 120 days after it's been deployed. And then the last thing that I want to discuss about setting up the nodes, so the initial configuration, is NTP, which is also very important. NTP, as we all know, stands for the Network Time Protocol. And basically the SAN needs to be able to communicate with an NTP server so that all of the nodes are registering the same time. And this is important really for making sure that logged events get logged with the proper timestamp when you're troubleshooting things. It's many times difficult if you have different devices with different times to know exactly what's going on at what particular time. And the way that NTP is registered is if you go to the network tab, actually you'll see it. Actually, you know what? NTP is actually configured. It's actually not configured on the host level. It's actually configured on the management group level. We'll actually get to that. I should have put it under the management group level. That's something that's configured really on the management group, and then the management group will synchronize all of the nodes together. So we'll get back to NTP in a moment. The one last thing about configuring the individual nodes to know is differences between physical and virtual. So when you're deploying the virtual SAN, the difference is you first have to follow the procedures like we did together. There's a wizard for installing the virtual SAN, which allows you to configure the amount of storage that you're using. It'll also allow you to configure the IP address of the virtual SAN node that you're deploying. And then in VMware, once you boot up the SAN node, you can actually view the console of the SAN node, and it will look the exact same as the console of a physical node that you boot up. You'll see the same text-based screen that says login, and it allows you to go in there and change the IP address, and that's pretty much all you're able to do. As far as bonding is concerned, you would do the same level of bonding. Bonding is actually a little bit different with the virtual SAN. Because with virtual SAN, we're only really dealing with one second actually. There's actually two different types of deployments that we have. With most of our virtual deployments that we do. We have dedicated SAN nodes that are. I'm sorry, I'm just losing my train of thought for a minute. With virtual SANs, because we have virtual NICs that are assigned, we don't have to do any bonding on the SAN IQ part of it.
It's done on the
It's
ESXi
really
level.
exactly. It's done on the ESXi level. So therefore, you're not going to really see this ALB, balance ALB, and you're not going to really be creating bonding from the NICs because they're all virtual NICs anyways in VMware. Okay, I think that pretty much sums up what has to be done. So in other words, just in review, just the procedure. You're starting up a new SAN, right? A new SAN infrastructure. You've completed your SAN worksheet. You've either cracked open a box on a physical SAN, or you're deploying a virtual SAN using the wizard. So when you connect to these units using the CMC, all you're going to see pretty much is just these SAN units that you have configured showing up, and they're not going to be part of any other infrastructure. They're not going to be part of any management group or clusters, which we'll get to shortly. But they're just going to be standalone units that are unconfigured from a storage point of view, but just configured from a licensing perspective and a networking perspective.
When you first open the console.
When you first open the CMC and you connect to an unconfigured SAN network, all you're going to see.
Using their IPs.
Exactly, using just the IPs, you're gonna basically there in the CMC, there's a place here called Find, and you click on Find Systems. Typically, it'll find it on its own, but sometimes you have to actually add in the IP address of let's say the first virtual SAN or physical SAN in here, and then once you click on Find, it will find that and then add it over here as an available system for a configuration. Okay, so let's get into some of the meat of the how the SAN is structured and organized. The first level of organization when creating a SAN or pool of storage is something called a management group. This is something that exists with HP. Other vendors have different terminologies, different names that they use. But for Store Virtual, there's a concept called a management group. A management group is basically the highest level of logical grouping for SAN units. Typically with most small implementations, you're just going to have one management group. If you have a multiple site location, then you're gonna want to create a separate management group for that other site. If you're dealing with, let's say, a DR location and you want to replicate, then you're going to create a separate management group for that DR location. Another time you'd create another management group is if you had, let's say, two different companies and you had two different administrators. Management groups allow you to set security on the particular management group, so that only certain people have access to this management group, and people can't access volumes on another management group. Most of our deployments, like I mentioned, we're only going to create just one management group, the naming convention that we follow for creating management groups, as you see over here, I've clicked on what the management group level, which is pretty much, actually it's this one, the top, which is pretty much the top level. We typically, using a naming convention of company name, and then underscore, and then some sort of designation for the location. So in this case, it's ENJ, which is for GNA Edison, New Jersey, underscore group, underscore one. Sometimes you'll find, if we had two different locations, like another client of ours, Help USA, that had a set of SAN nodes in their main location called Hanover, then another one in DR, so we would have called it Hanover underscore one or DR underscore one. But typically, most of our simple implementations is just gonna be company name, location, and then group underscore one. Now, it's extremely important you should check with management before naming your groups, because this is not something that's editable, and it's extremely important to follow convention so that we keep things consistent amongst all of our deployments. So it's always good to make sure that someone from management reviews it before you actually put it into motion and click finish on that configuration wizard. So when you create the way you create a new management group is there's actually a wizard. If you look at the SAN startup page, there is a place here. Click on management group, new management group, and this will bring up this wizard, which is welcome to the management group clusters and volume wizard. So this will allow you to actually configure a lot of things all in one wizard. So the first thing you're going to do when you click next on this wizard is you're going to create a new management group, and then so right now the wizard is not letting me create it because there's one that already exists in this particular location. But basically, you would click on new, and it would over here click next. It would allow you to name the management group as this one is named with this convention. Now, what's important to know about management groups is there's a function of each of the nodes, something called managers. This is a very important concept on what a manager is. I decided to create a copy of what the manual that describes exactly what the functions of managers are, because they lay it out, pretty well. So if you just pull up the handout that we have over here. Managers overview. Within a management group, managers are storage systems that govern the activity of all of the storage systems in the group. All storage systems contain the management software, but you must designate which storage systems run that software by starting managers on them. And you can see that if you look at any node, you can right-click any node, and you can either start or stop a manager. If it says stop, it means it's running the manager. If it says start, it means it was stopped.
And by node, it's a physical or virtual?
Exactly,
VSM?
yeah, exactly, the same thing, whether or not it's physical or virtual. Each SAN node has the ability to run a manager or not run a manager. Now, why would you want to turn one on or off? We'll get to that in a moment. But basically, the functions
There's
of
only one manager per group.
no, you'll see in a minute. Functions of managers. Managers have the following functions. Number one, they control data replication. Number two, they manage communication between storage systems in the cluster. Number three, they resynchronize data when storage systems change states. And number four, they coordinate reconfigurations as storage systems are brought up and taken offline. One storage system has the coordinating manager. You can determine which storage system is the coordinating manager by selecting the management group, then clicking the Details tab. The status field at the top shows the coordinating managers. So if we go over here to the management group, okay, and then we go to the Details tab, which is what we see over here, it will show which one has the coordinating manager. So here, as you can see, the coordinating manager is SAS02. Okay, there's three managers configured, 3 regular managers. So what does that mean? So let's look at the next paragraph. Managers use a voting algorithm to coordinate storage system behavior. In this voting algorithm, a strict majority of managers, which is called a quorum, must be running and communicating with each other in order for the SAN-IQ software to function. And this is an extremely important sentence. An odd number of managers is recommended to ensure that a majority is easily maintained. So you always want to make sure you have an odd number corresponding to the number of nodes that you have. And the reason is because an even number of managers can get into a state where no majority exists. One half of the managers do not agree with the other half. This state, known as a split brain, may cause the management group to become unavailable. So for optimal fault tolerance in a single site configuration, you should have 3 or 5 managers in your management group to provide the best balance between fault tolerance and performance. The maximum supported number of managers is 5. So here we see a chart based on the number of managers that you should have, in which, as we stated, 1 and 2, having just 1 and 2 is not recommended. You have to have.
You only have 2 nodes.
Okay, so very good. We're going to get to that. So let's first assume you have. Let's first assume that you have 3 nodes. So if you have 3 nodes, you should have 3 managers. If you have 4 nodes, you should still have 3 managers. If you have 5 nodes, you should have 5 managers. If you have 6 nodes, right, you should have 5. So basically, you always want to make sure you have an odd number of nodes. Now, your question: what happens if you only have 2 nodes? What do you do then? So basically, that's where this second concept comes in, which is called a specialized manager. What's a specialized manager? So there's 2 types of managers. We have regular managers, which are the ones that run on real nodes, okay? And then specialized managers are managers that are that can run on a separate device, which its only function is to provide a manager. Now, there's actually 2 types of specialized managers. There's one called the virtual manager, which is not recommended to use, but basically all it is you actually don't even see it here, but when you create a new SAN infrastructure, you will see something called a virtual manager that'll show up in the CMC, and it'll allow you to turn it on or off, depending on whether or not, you have a, whether or not you need an extra manager or not. The issue is that, you might have a problem. You might not be able to turn it on if you don't have a quorum. If you only have two and one of them fails, you lose quorum, because you need at least two managers to maintain quorum, and you won't be able to turn on or off that virtual manager. So that's why it's not recommended to use, and we don't use it in any of our deployments. The other type of specialized managers is called a failover manager, and what that is actually a virtual machine that runs a special version of the SAN-IQ software that is not used at all for any storage purposes, but simply for running a manager. Now, the idea is you want that failover manager to run somewhere that's not part of your SAN infrastructure. You want that to run on a completely separate, either a completely separate server or storage that's outside of the units that you're using for the SAN. So typically, in all of our deployments, we typically install the failover manager on the management server. So that's why it's important actually to have the management server as running a server OS, because the server OS allows you to enable Hyper-V, and the HP left hand has a wizard that allows you to deploy a failover manager to that Hyper-V server, that management server, and then at that point, you already have connectivity to the SAN network via the NIC that you're using on that management server already, and it's a completely separate unit, so that it will allow for, if either node fails, you'll still be able to have quorum or enough managers running to be able to access that data. So in this particular case at GNA, they have four units. So we don't. They actually got 2 units, fairly recently, about 7 months ago. But before that, they only had 2 units. These original 2, SAS01 and SAS02. So they actually had a failover manager that was running in Hyper-V, which you might still see if I bring up the Hyper-V console. The server was definitely turned off because it's not needed anymore. Okay, yes, we definitely have a lot of clients that have it. Whoever still has 2 nodes, and as you can see over here, this was the running, they used to be running failover manager for GNA. It's now off. No reason to keep it on anymore because we have enough managers that can step in the event one unit goes down. But with 2 nodes, basically we have to have that failover manager, and that failover manager will step in and provide a manager to allow you to have access to data in case one of the 2 nodes go down.
So it's a left-hand OS VM.
Exactly.
We don't have a version which you could just install on Windows as an application.
Correct. It's correct because it's running SAN-IQ software. So you're right. It's not software that runs on Windows. It's software that runs on their SAN-IQ, which is Linux based. So yes, it has to run in a virtual machine, either on Hyper-V, which is easy to do with the management servers that we have. You could also run it on VMware if you have another machine that's running VMware. They have a no, they don't recommend you running it on workstation. Either ESXi or Hyper-V.
Level 1.
Huh?
Level 1 Hyper-V.
Correct. Level 1 hypervisor, exactly. Okay, so once we have our management group, part of the wizard will walk you through joining your nodes to that management group. So when you turn up a new node and you don't have a management group configured yet, you'll see something that says available systems. It will show you a list of unconfigured or unjoined nodes. And the goal is to get those nodes joined to a management group so that you can properly manage them from the CMC. So the wizard will ask you which nodes do you want to connect, and typically you're going to say all of them. And then at that point, once it configures it, it will place those nodes under this heading over here, under the management group heading. And as you see over here, we have 4 nodes that are under this management group. So once you have management groups, once you have nodes that are under a management group, and they're being managed, by that management group, one other important thing that it allows you to do is shutting them off. With any of these nodes, whenever you shut off either a physical or a virtual SAN, you can shut off individual nodes if needed by right-clicking and then choosing power off. Okay, but if you're in a situation where like a power shutdown, right, where you want to shut all nodes at once, you don't have to individually shut off each node. You can simply right-click on the management group. So over here, you right-click on the management group, and then choose Shutdown Management Group. Okay, and what that will do is, once you click this, that will basically initiate a shutdown command to every single node to completely power down. Finish any replication that you're doing between each other, and then immediately power down.
But before that, you have to shut down the VMs.
Yeah, of course, definitely. If you're doing a power shutdown, the SAN nodes are the last things that you're going to shut down. And in a virtual SAN, also the virtual SAN is going to be the last thing that you shut down. First, you will shut down all of the virtual machines, and then all you'll have are the 2 VSAs that'll be remaining. And then at that point, through the CMC, definitely don't power off the VSA from VMware. That could potentially be catastrophic. You want to always shut down or reboot, whether it's physical or virtual nodes, from the CMC.
And it turns off the VM at the end?
Yes,
VSA?
exactly. It will turn off the VSA completely, and it will show up as off on the. And just to show you an example of I could show you Excelco. Excelco is a very good example. Just to show you an example of a VSA. Here, this is actually, we're connected to one node over here. Try to connect to vCenter. So if we look here at a vCenter managed infrastructure, we see both of our nodes over here, and they're running virtual machines, right? And in addition to that, here are the 2 VSAs, VSA1 and VSA2, okay? And as you can see, basically if we look at our hosts, and we go to the configuration tab, and we go to storage, we can see that the original storage that's on the unit itself, okay, which is this, is 3.27 terabytes, okay, and
It's directly attached to.
that's directly attached to this HP server, okay. But we have a VSA that's in there. If we browse this data store, you can see that I have the only machine running on that data store is my VSA, okay, and this VSA is basically taking up, most of that 3.27 terabytes, right? There's only 40 free, and that VSA allows us from to within the CMC to carve out storage, which is what these other volumes are over here. So if I look at my CMC over here at Excelco, you'll see that I have, various volumes. Some of them are VMDK volumes, which I've indicated with, putting VMDK first over here. So the way we name our we'll get to volumes in a minute, but the way we name our VMDK volumes are VMDK_1_2, or sometimes we can name them if let's say there are a group of VMDKs that are for an Exchange server, we might do VMDK_EX to denote what's inside, or in this case we have VCS, which stands for vCenter. So the VMDK for the vCenter would be created in there, which we spoke about. In the past we did vCenter inside the cluster, but there seems to be a better line of thought now to put vCenter outside. But that also assumes you need to have a domain controller as well that's external to the SAN. So that's another thing we should talk about. But these other volumes, as you can see by the column device, says that they're left-hand volumes. So each of these are being accessed, from the carved-out storage inside the CMC.
Those are basically VMDKs under
Yeah.
the
We're
VSA
gonna-
VMDK.
Yeah, exactly. We're gonna get to that, in a moment, how the actual volumes work. But I just wanted to at least show you what a VSA looks like as opposed to a physical SAN. GNA is running a physical SAN, and Excelco is running a virtual SAN. Okay, so once we have our SAN nodes inside a management group, the next important concept is a cluster. So what is a cluster? A cluster is what actually takes the storage nodes, pulls them together to become one storage. So for example, if I click on GNA's cluster over here, which is basically, if I collapse everything in the CMC, right? The highest level of administration is the management group, right? And then just collapse all these. And then once I have my management group, okay, I have the next thing that I have available. We'll get to what these are in a minute, servers and events and whatnot. But the next level that I have under a management group is what's called a cluster, is my clusters. So clusters, like I mentioned, is where you can take together various storage systems and put them together to become one big pool of storage. So a lot of our smaller clients have just really one cluster, but you can definitely have situations where you have multiple clusters. A couple of examples are, they do make storage units that have faster SAS hard drives. They have storage units that have SSD drives, which are extremely fast, extremely expensive too. They also have storage units that have slower SATA drives. What's important is not to mix in a cluster storage that are not similar to each other. This rule actually could be changed, could be broken in later versions of SAN IQ OS. They actually created a way to lessen the impact of that. It's called storage optimization. But leaving that out for a moment, in general, you want to create clusters that are of the same type, the same compatibility of speed hard drives. Because if you have a faster unit in a pool of storage and a slower unit, the faster one can only go as fast as the slow one, and you may have issues where the faster one is always waiting for the slower one to catch up in replicating, so it could cause some performance issues.
So you can't put a mix of SSDs and SAS drives in a single node.
Oh yeah, that for sure you'll never find. That you won't. On the same node itself, you definitely don't want to do that. On the same node itself, you want to make sure that all the drives are the exact same. They're all either 10K RPM, or 15K RPM, SAS drives. They're all the same model, or if you're using SATA, all of the ones on that node are SATA, and then you build your clusters, with nodes that are alike.
So if you want storage tiers, then you need a SSD cluster and
Yeah, so in
Something
other words,
like that.
you can do it like this. In other words, one of our first implementations, we had a SAS cluster that was used for higher performance storage, running databases, Exchange, Oracle, SQL, and then we had a SATA cluster that was basically used for design file storage. It can run on slower disks. No issue doing that, and then but the important thing is to make sure that those clusters are separate from each other. So in this particular cluster at GNA, we have 4 storage systems because they're all the same more or less. They're all running SAS hard drives, so they're joined together to create one big pool of storage. And if you highlight the like I have over here, I have the cluster highlighted on the right. Under the first tab, which is the details tab, you'll see what is my total space for this cluster. It's 11 gigs. I'm sorry, 11 terabytes rather. 11,324 gigs, which translates to about 11 terabytes. And it shows me right away what my available space on that cluster is, which is 3 terabytes. And you see my used space, and it gives me a percentage of my utilization. So this is an extremely important screen to always look to make sure that your SAN utilization, is not creeping up and potentially running out of space. 73% is perfectly fine. That's good. When you start getting into the high 80s, that's when you have to start worrying that there might be that you might be utilizing SAN space too quickly.
can you
And then at
increase
that
on the
point,
fly?
yeah, can you create what?
No, increase.
Oh yes, most definitely. If you need to increase a volume, we're going to get to that. But if you need to increase a volume, you can always increase. You can decrease too as well, but that's a lot more dangerous. Typically not done. We always try to create volumes as small as possible to accomplish what we need, and only then increase if needed. Because taking space back is much more difficult than increasing space.
Is this space on the volume or space on
This
the...
is on the cluster,
on the
on the
cluster.
entire cluster.
Space on the
Because if you
cluster,
look,
so-
because if you look at each of these, if you highlight each of these individual nodes, you'll see this one is 3.27 terabytes. This one's 3.27 terabytes, right? This one's also 3.27 terabytes, and so is this.
Right.
Right? So all of these add together to one big pool of storage of 11.3 terabytes.
But if
So-
you're running through space on the cluster itself, is it simply just popping in another drive on an available bay?
Well, it's not an available drive. You would actually have to. There are methods of trying to get space back, but the way to increase it is simply to purchase another SAN unit. And that's one of the most lovely things about SAN is that I can just purchase I can increase the storage at any time by purchasing a brand new unit, making a SAS 05, right? I would basically plug it into the network. I would configure an IP address. It would show. I would click on find systems. Okay, I would put in the IP address of that node. It would find it. It would show up under available systems. I would right click on the node and say add to management group. Okay, and then it would bring it from available systems down here inside the management group. And then at that point, I can add it directly to this cluster and increase the storage space of the cluster from 11 terabytes, 0.3 to another 14 terabytes. And then I've just easily increased my available storage pool without affecting anything. Something that can be done at any time during the day. It won't interrupt any operations of the SAN. And then at that point, all of the volumes will restrike themselves to take advantage of spreading the parity over the new SAN node. And it's really nice.
In case of virtual SAN, when we have many
Virtual
more...
SAN is a lot more difficult because you would have to. The reason why it's difficult is because SAN models change frequently. Server models rather change frequently, and hard drives as well change frequently. So you have to make sure that you're buying the same model server as the original 2 that you have. If you have, let's say, a 2-unit model that you started out with, and you're adding a new one, you want to make sure that the third model is the exact same model or extremely similar to the original one before adding it, to the cluster.
But we have much more empty slots for more hard drives in the
Okay,
existing
okay,
one.
so yeah, so correct. So if you do have empty slots for an existing server that has the virtual SAN installed on it, so it's actually not so simple. There is a procedure to follow specifically for virtual SAN in increasing the space. In other words, you can't simply just extend it in the VMware side. You actually have to create another virtual hard drive in VMware. But in the SAN IQ, it allows you to join those two VMDKs together to be able to create one big pool of storage. It's a
But
little,
you
it's a
can-
little
you can
messy,
do
but
it.
it's doable. Yes, it's a little messy, but it's
So
definitely
it's a recommended
doable.
method on a virtual SAN.
Well, no, it is recommended. You can do it. You definitely could do it. It's just you have to make sure you don't extend the original SAN in VMware. That's what I mean. That's extremely important to not. Don't just edit the VSA and say, oh, I have more hard drives now. I can increase it from 3 terabytes to 6 terabytes. That you cannot do. You have to follow a procedure in the HP Store Virtual Manual for vSAN on how to create a new VMDK and how to join that to the cluster that way. So there's a special procedure for that. So it's a little bit more complicated on a virtual SAN, versus a physical SAN where it's more or less plug and play. But it's definitely
Which is more
doable.
expensive.
Oh yeah, definitely more expensive than virtual SAN. Okay, so naming conventions for virtual SAN for clusters. It's kind of similar to what we have with our naming of the management group. We basically have company name _ location _ and then the characteristic of the nodes that you're joining. So either SAS1 to indicate you're creating a cluster made out of physical SAS drives, SATA1 to indicate a cluster of SATA drives. If you're doing a VSA, as you can see at Excelco, we call it VSA-SAS, so that we know that we're dealing with a VSA, and we're also dealing with servers that have SAS drives as opposed to SATA drives. Could be in some other ones we just have VSA _
Also,
1.
if it's virtual,
but,
we add VSA before the type of drive.
Yes. Okay. So now, one other important concept with clusters is how do you connect to a cluster? How do you actually connect to the storage? Because as we know, each of the individual nodes have IP addresses. So if I'm trying to connect to a volume, how do I address the cluster as a whole? So that address is something called the virtual IP. It's called the VIP, the virtual IP address, and that's something that actually gets configured when you go through the wizard. That wizard that I showed you before, where you're able to create your management group and then create your first cluster. The third thing you're going to set is what is the VIP IP, the virtual IP address. And if you look at your SAN planning worksheet, which I'll bring up over here, that's noted over here as the cluster IP. So as you see over here, GNA has 4 nodes. They have 9.90, 91, 92, 93. Okay, and all of these nodes are addressed with a cluster IP of 9.100. And 9.100, that's the central IP that you're going to use, whether or not you're connecting an ESXi host, or a virtual Windows machine, or even a physical Windows machine if you're doing that. When you get to the settings of in the iSCSI initiator of what IP address to put in, you are going to put in this IP address, the VIP IP address. And if you go back to the CMC, you'll see where that is noted. There's a tab when you click on the cluster on the left side. On the right side, if you go onto the iSCSI tab, you'll see over here it will show you what your virtual IP is. So it says here virtual IP. Virtual IP is required for fault tolerance or load balance iSCSI sessions. And the way it works is that the SAN IQ is able to take traffic from this IP and load balance it onto the individual nodes to be able to access data in the fastest method possible. So basically that iSCSI tab will show you what your virtual IP is. In this case, it's 9.100. If we look at Excelco as another example, if I click on the cluster and then I look on the iSCSI tab, in this case it's when I do iSCSI, that's 0.100. No, the sum that used over here was 0. Okay, so yes, we reviewed capacity monitoring, we reviewed cluster best practices, which is basically to make sure that we keep the same type of nodes in a cluster, running the same hard drives, and not to mix so that when planning SAN, many times if let's say you had a so in other words, as I mentioned before, we can easily increase this storage by adding another node. We have to make sure we add the same node. We have to add the node that's got the same types of hard drives that will be compatible with this cluster. We want to have a node that's running either much faster or much slower hard drives in the same cluster. Okay, last but not least is our volumes, and that's our lowest level. Actually, there's even lower level snapshots, but we'll get to that afterwards. Volumes is where the heart of it all is. Basically, as I mentioned, we have our big pool of storage. If we look over here, right, a GNA, for example, we have 11 terabytes. So the way we use our storage is by creating volumes in the SAN, and then those volumes we can then assign for presentation to whatever ESXi or Windows server that we're creating. So, for example, over here, let's say I wanted to create a volume called test, right? I'm going to create a volume. Okay, I'm going to call it test. Now, this volume that I'm creating, this is just a volume on the SAN that basically is just a blank container on the SAN. SAN doesn't care what you put in it, what file system you put in it. You can put on it an NTFS file system and connect to it via Windows. You can create a VMFS file system and connect to it via ESXi. SAN doesn't know, SAN doesn't care. All it knows is I'm reserving this amount of space for whatever you want to put in it. So I'm going to create just a test volume over here. I'll just call it test 1, okay, and I'll make it size 2 gigs, okay. And then if we go to our advanced tab, okay, I'm able to choose what cluster it's in. In this case, I only have one cluster, so it's going to stay on this one cluster. And then the other important concept is data protection level. So what this means is every volume allows us to choose what sort of protection that data has in the event a node would go down. Is the data still available, number one, or is the data even there in the first place? So this is the data protection level is given based on RAID levels. And this is very similar to disk RAID levels. Just like in a disk RAID, right, if you take two or three drives and you would put them in a RAID 0, what happens if one of those drives should fail?
Work.
In a RAID 0?
Mirroring?
No, not mirroring. RAID 0
Striping?
striping. Yes.
But it's dead. Okay.
Exactly. You would lose all your data. So that would be this setting over here, which you almost never want to use, because what this means is it only writes the data once, and it could be on any of the 4 nodes. If one of those 4 nodes should suffer a failure, you would lose that data forever. So you almost never want it. It does use the least amount of space, but obviously that comes with zero fault tolerance in the event of something going down. And part of one of the most important concepts of SAN is fault tolerance. Because we have all our eggs in one basket, we want to make sure our basket is extremely secure in every way possible. All of these nodes have redundant cooling, redundant fans, redundant power supplies, and we build redundancy in the SAN by making sure we configure our volumes in a way that allow for fault tolerance. So the other option to use, I'll skip RAID 5 for the moment, but the other option we have is what's called two-way mirror. Basically it's called RAID 10. This is also similar to two-way mirroring that you would do on a disk RAID system, where it basically writes to both. Let's say you have a two-node unit. It's going to write to both nodes at the exact same time. It's going to stripe and mirror to both nodes at the same time, so that you have complete fault tolerance in the event one of those nodes should go down. You'll still be able to run and have full access to that data on the other node. Now, obviously, because it's writing to both nodes, that's going to take away a lot of your storage. So even though you have a two-node system, if let's say you create all your volumes with two-way mirror, network RAID 1, you basically only have storage of one unit. And the entire second unit is pretty much being used for redundancy purposes. So your capacity for storage is cut in half. So if, let's say, I cancel this for a minute, just to get back to this screen. So even though I see over here, I have 11.3 terabytes of ready space. This is total space available without taking any redundancy or mirroring into consideration. So if I create a volume that's let's say 324 gigs, right? The reason why I say that is because it says 11,324. It's going to take up double that if I make it RAID 1, network RAID 1. So in other words, I lose a lot of my storage with the redundancy when I choose RAID 1. And typically, most volumes you're going to configure them with RAID 1. That being, it gives you the best performance, and it also gives you full redundancy in with however amount of nodes that you have, and being fault tolerant. The other option that you have, if we go back to our new volume screen here. Let's make this 10 gigs. Is we could create it with single parity network RAID 5. This is kind of like an in-between, where it'll take up less space than a full RAID 1. However, performance, though, does go down. Just like in a regular disk array, right? Performance on a disk RAID 5 is going to be a little bit less, for sure, on writing than it is with disk RAID 10. It's the same idea with network RAID 5 versus network RAID 10.
And you need 3 nodes.
Exactly. You at least need to have 3 nodes, so you're actually not even going to see it listed on a 2-node VSA. You're not even going to see it as an option. So for 2 nodes, you're always going to use RAID 10, two-way mirroring. You could do 3-way mirroring and 4-way mirroring, but obviously that's extremely fault tolerant, and you're going to lose a lot of your storage, and you'll fill up the SAN extremely quickly if you choose those. So
on 2 nodes, 10 or 1?
What's that?
On 2 nodes, RAID 10 or RAID 1?
Well, it's called RAID 10.
RAID 10.
Yeah, because it does both. It does striping and mirroring, and basically you're going to look for where it says two-way mirror, like it says over here, two-way mirror. So on two nodes, you're always going to do two-way mirror. With 3 or more nodes, you have the option of doing network RAID 5, which will allow you to have only single parity, and it will definitely save some space. But it's not recommended to use for any sort of databases, because of the write penalty that you'll get with network RAID 5.
And you
If
can
you're
mix and match those kinds?
You can mix and match, yes. In a cluster, you can mix and match volumes that have network RAID 5 or network RAID 1. It's not a problem at all. But it is fine though for file storage, because file storage doesn't really need very fast writes. So so getting back to one issue that we were mentioning before, what happens if you run out of space? So this is one technique in trying to, if you're getting to a point where your SAN utilization is coming close to 90%, and for whatever reason you can't get a new node out there so quickly. Client, it's an extremely expensive venture that the client hasn't approved yet. One technique is you can take a volume that originally was created as RAID 1 and you can easily convert it. You can right click on any volume, go to this screen, and you can select the volume, change it from RAID 5 to RAID 10, or actually, if you want to save space, you're going to go from RAID 10 to RAID 5, click OK, and then that will convert the volume. It will have to go through a resyncing with data on it. You can do it live, you can do it in the middle of the day, it won't disturb anyone, and it will get you some space back. So that's something that can be done in an emergency situation in order to get space back. So just to finish our example over here, I'm going to create a new volume here called test 1. I set it to 10 gigs. Okay, I'm going to keep it two-way mirror. Okay. It's going to be a primary volume because we're not dealing with any remote. A remote volume is if I had a DR site and I wanted to make copy, or even if it wasn't a DR site. Let's say I had dedicated SAN nodes on a different floor, or even in the same room that I wanted to just have copies of the data to create snapshots, which we'll get to later. Snapshots is a whole other topic. I have the ability to do that and make the volume a remote volume, but that's a separate topic. We'll get to that another time. The other important concept when creating a volume is the provisioning. So there's two ways you can provision a volume. You can either provision it full or thin. A volume that's provisioned full is pretty simple to understand. I set this volume to be 10 gigs right now. If I leave the provisioning as full, what that does is that will tell SAN cluster to dedicate the entire 10 gigs, take it out of the pool of available storage right now, even though I didn't put any data on it yet. But it will take the 10 gigs out of the available pool of storage and dedicate it so that it cannot be used for anything else. No other volume or no other, nothing can ever take away these 10 gigs that's dedicated only for this volume from the available pool of storage. So the issue with doing that is many times you create a volume, but you're not going to use all that space, right? Let's say you create a volume that's 100 gigs. That's for a file server, right? I'll make the example more. Let's say you do it 500 gigs, right? But it's a young company. They're just started out, right? And they probably only have about 100 gigs of data, right? So now you have 400 gigs of data that's sitting there. That the SAN won't let any other volume touch, right? It's dedicated for this file server, and I can't use that storage for anything else. If let's say my Exchange server, right, needs storage, and I want to be able to take from storage, from available storage, and use it for my Exchange server, I have that space now that's sitting in my file server that I'm not able to touch because I have this provisioning set to full. So the option that you have is, which is one of the biggest benefits of using a SAN, is that you can set the provisioning to thin. And what thin means is that the SAN is not going to dedicate that storage, this entire 10 gigs, to this volume only. Rather, it will only dedicate that storage on an as-needed basis. Meaning, until I copy the 10 gigs to this volume, it won't mark that storage as used. It will basically, it'll basically, provision that it's available for use. But if something else needs that storage, you can assign that storage is still in the available storage section to allow me to assign it to another volume. Just to illustrate this, notice how it says over here my total space is 11,324. So if I had set my 10 gigs to full, this would have decreased immediately, the available space here, from 32.4, it would have said 30.14. Because when I full provision a volume, it takes the space away immediately from the cluster, and that 10 gigs is not assignable to anything else. However, if I set the volume to thin provisioned, my available space will stay the exact same, and nothing will change until I start putting data on there. So if I take a 10 gig file and then I copy that 10 gig file to the cluster, then as I'm copying the file, you will see this, decrease. It'll go 30 to 23, 22, 21, 20, until I finish copying that 10 gig file, then it will say 30.14. So now, what happens if, right, let's say the volume that I connected to this to is a Windows server. What happens if, let's say, I delete that file in Windows? What happens then?
Does it reclaim?
Does it reclaim? So traditionally, most SAN units do have a feature of reclaim. HP Store Virtual did not have that feature for many years. They actually did release it in version 12.0 and up. So the reclaim feature does require, though, a Windows 2012 R2 and up in order for you to have that reclaim happen automatically. There is a way to reclaim space with older OSs with the use of third-party utilities. One utility being a program called Perfect Storage, which we actually have installed. You may have seen it at J. Franco. So there's a piece of software there that allows us on older OSs to be able to communicate with the SAN and tell the SAN, hey, I deleted this file. Please reclaim the space on the SAN and add it back to the available storage pool.
Well, not this all relates to in-host iSCSI.
So in my example, yes, but ESXi does have the ability to reclaim space as well from version, I think it's 5.1 and up.
And you have to make it thin provisioned inside.
Exactly.
ESXi.
You have to, exactly. Now, the thin provisioning is not something that you have to decide and can't change afterwards. Any volume I can always change. So for example, this volume I set it as thin, this test volume that I created, I can go back into this volume, I can go into advanced, and I can set it now to full. Okay, and notice how the consumed space immediately changed to 20. Do you know why it changed to 20?
Instead of 10?
Yeah, instead of 10. The reason is because I'm doing network RAID 10, two-way mirror. So it's dedicating the full amount of storage, including replication, right, to this volume, and taking it away entirely from the cluster. So basically, if I go back to my cluster now, I'll see that this went down by 20 gigs, my available space. But I can go back in here, and because it's an empty shell with nothing in there, I haven't put any data back. I can go back here, choose edit volume, go to advanced, and say thin, and click OK. And now you'll see my consumed space went back to 1, which is the lowest amount, even though there's nothing in here yet. But that's the lowest amount that it considers being used. And then if I go back to my cluster, I'll see this jump back now to 3020.
Now, you match one cluster volume to one ESXi or Windows volume, or you put multiple ESXi or Windows volume?
Okay, that's what we're going to get to next. So now, how do I connect to this test one volume? Right? So for this example, what I'm going to do is I'm going to connect to this volume from this physical server that I have here, the management server. You can connect to, you can connect to the volume, from virtual machines, physical machines, running Windows, and ESXi. So just as an example, I'll show you how to connect to this volume from a Windows machine. What's required to do that is you must go into the iSCSI initiator. So that's always found if I click on Start, Administrative Tools, iSCSI initiator. Okay, so now every iSCSI initiator has to have what's called, if I click on the configuration tab, has to have what's called an initiator name. This is the name that is used to identify this machine as a machine communicating via iSCSI. And the SAN has to be aware of this name to allow access to the volume. So where do you input this on the SAN? So there's a section in the SAN under the management group called servers. So you see over here under the management group, I click the plus under servers, okay? These are the servers that are allowed access to SAN volumes, okay? So what I'm going to do now is, as you can see, the management server is not on here because we never had to connect yet to a volume on the SAN from the management server. So what I'm going to do is I'm going to create a new connection, a new server that will allow me to connect from the management server. And you do that by right-clicking the server and choosing New Server, okay? And then the name, we put in the name of the server. So in this case, the name of the server is SERGA back1. This server is also a backup server at this client. SER-GA-back1, okay. And then we could skip description and skip controlling server IP address. That's a different topic. So basically, the initiator node name, this is where I'm going to put that long string from the iSCSI initiator on the Windows server that I'm trying to connect from. So if I go here, I can highlight this entire thing, okay, right click, choose copy, okay, and then paste it in here. Right click, paste, okay.
Servers will have that name even before they have any connections.
Yeah, exactly. Yes, this is basically a generated name from Windows for the iSCSI initiator. Okay, and then click OK, and then that's it. My server now shows up over here. So now, right now, I don't have anything assigned to this server, right? Because it's a brand new server connection that I just created. So the next step is I need to assign which volumes are gonna allow connections from which server. So in our case, what I want to do is I'm going to take this test1 volume that I created. Okay, I'm going to right click on the volume, and I'm going to say assign and unassigned servers. Okay, so once I choose that, I will have a screen showing me a list of all of my server connections to choose from to assign this volume to. So, I should see my new, oh, here we go. So I'm going to assign this now to the new server connection that I just created here, back1. I click assigned over here, and then click OK. So now I've assigned and allowed connectivity from back1 to this test1 here. So if you look at the server connection, look at volumes and snapshots, you'll see which volumes are allowed connection, which servers rather are allowed to connect.
Can you click on the server and choose volumes to be assigned?
Yes, you can do it the other way exactly. I can right click on the server itself and I can say assign and unassign volumes and snapshots. It's much harder to do it this way because you see a much larger list of volumes and snapshots to choose from. So
snapshots are listed too.
Exactly. You can assign a snapshot to any server. I can mount any snapshot, which you've done many times for restoration purposes. You can take any snapshot or any volume and assign it. The thing you have to be extremely careful about is, when dealing with NTFS volumes. Right now, this is an empty volume. Because we're connecting it to a Windows, we're going to soon format it NTFS. You must make sure NTFS is not a cluster-aware file system, meaning you cannot have two servers connect to the same NTFS volume at the same time, or else you risk corruption, which will surely happen. So therefore, you have to make sure that you only assign for NTFS volumes one volume per server. Extremely important. So in this case, I assigned test1 to my volume, to my server rather. So now I can go back into my iSCSI initiator okay? So now I wanna be able to connect to that volume. So in order to do that, I can go to the Discovery tab, okay? And then I can click on the button Discover Portal, which will allow me to type in the IP address of the SAN cluster so that it will communicate with the SAN cluster and ask it what are the available volumes for me to connect to. So I'm going to type in the IP address of my SAN cluster, which, as we know in this particular example, is 192.9.100. Click OK. All right. And now, if I click on the Targets tab, I'll immediately see, for presentation, the SAN volume that I created, test 1. So it says status inactive. So now the next thing I need to do is I need to actually connect to it. And the way I do that is just have it highlighted here, click on connect. Okay. And then what's important in this screen is we want to make sure, this is by default checked, you just want to make sure it stays checked. This option says add this connection to the list of favorite targets. Favorite targets is the list. You'll see it's a tab on the iSCSI Initiator where when the server gets rebooted the next time, it will automatically mount this volume, and that's obviously extremely important. If it's a volume that we want to persistently show up on that server, we want to make sure that that volume is going to be on the favorite targets list so that it always mounts whenever the server is rebooted. An example of that when you're restoring from, let's say, a snapshot, then we don't want to add it to the list of favorite targets. So then we would uncheck it because it's something we're only doing temporary, not persistently. But when we want something to be persistent, we have to make sure that that's checked. Then we click OK. And actually, you know what? Before I even do that, one of the things I want to show you is I'm going to, before I click OK, because that will immediately make the connection to the iSCSI volume, I want to just show you in disk management what's going to happen when I do that. Right now, if I load disk management, so this is a physical Windows server, right, that has, you'll see in a moment what its storage looks like. I click on disk management. You'll see that I have basically a C drive, okay. Then I also have, so that's really the only drive I have. That's local, that's directly attached storage. Then I think there's also 2 external drives. These 2 are external drives that are plugged in, Passport and another external drive. So I have 3 disks, right? 0, 1, and 2. 1 built in, the C drive, and 2 that are just externally connected disks. Once I go here, if I minimize this for a moment, and I click on OK, this will now say connected. And I don't know if you noticed on the right, an active connection just came up now over here on the CMC. But more importantly, if I look at Server Manager, I now have my 3rd disk that showed up, disk 3.
Oh, you don't even need to refresh?
Nope, don't even need to refresh. It just comes in like that. So now, whenever you connect a new SAN drive, it's always going to show in an offline state. So that's easily rectified by right-clicking it and saying online. So because it's a brand new volume that I just attached, you would get the same exact thing if, let's say, I took a hard drive and just added it to another SATA port. You would have the same thing. Assuming it's a drive that was never been formatted, straight out of the factory, not meant for a PC, it would show up like this as well. So the next thing you need to do is initialize the drive. And the way you do that is you right-click on the disk. You have to make sure you don't click on the graphic part over here, but rather click in the box under the disk and choose Initialize Disk. Okay. And then it will give you a choice on how you want to initialize it, whether or not you want to use MBR or GPT. And it's an important decision. MBR is the original method for partitioning, which was back in the Windows days. That stands for Master Boot Record. Windows can only boot from MBR. I believe maybe later version of Windows might be able to boot from GPT. Yeah, 2012. but historically, Windows has only been able to boot from MBR. And the extremely important thing to remember about MBR is that you have a hard limit of 2 terabytes on the size of the volume. An MBR volume cannot grow larger than 2 terabytes. So that being the case, we almost never want to leave our volumes that we're creating as MBR. The reason being is that typically the volumes that we're creating, like we just did right now, are additional volumes. These are not volumes that you're booting from at all. GPT is the newer partition tables, size that's replaced MBR, and therefore we should always make sure to choose GPT, which will allow us to create, extremely large volumes. I don't think we'll ever come to the limits yet, but maybe in 10 years from now we might. But especially the way data is growing.
So all GPT, all data volumes are created.
Exactly. All data volumes you should create a GPT, and then click OK. Okay. And now at that point we've initialized the disk, and that leaves us now with 9.97 gigs of unallocated space. At this point we can right click and choose a new simple volume in Windows. Click Next. Okay. And then I'm going to leave the full amount of the volume that I'm going to format. Click Next. Okay, I have the ability to assign a drive letter. I'll just choose I. Okay, click Next. Okay, I'll name my volume test 1. Okay, leave perform a quick format checked. Click Next. Click Finish.
You match the names to what's in the cluster.
Okay, so I'll get to naming conventions of volumes in a moment. You're right, test 1 is actually a very bad example of how we name. Usually the way we name volumes on a SAN is we name it, if let's say there are additional volumes that are showing up for an existing server, we'll put server name, so like in this case you see SVR-GA-DW1, right, or FS1, or OR6, or OR7, right, so it's a server name.
On the cluster we're talking now.
Yeah, correct. Underscore, and then the volume label. So the volume label will be, if let's say, if this is a file server that we're creating, typically we create a D drive, we name it data, so then that would be the name you would put in here. If it's if it's a log volume, called log. If it's a dedicated exchange volume for the general database, it would be called general, or executive, or production, and then underscore, and then in capital letters the drive letter that is going to be used in Windows. So D for David. So with this volume test 1, if I would have named this properly following the proper naming convention, the name would be SVR-GA-back1 underscore, okay, test 1, or data, or whatever volume label I want to give it in Windows, underscore I, because that's the drive letter that I want to assign it. For VMDK volumes, which we'll get to shortly, but VMDK volumes that are going to be mounted and accessed only from the ESXi hosts, those we name starting with VMDK underscore, and then either a numbering system, 1, 2, 3, or sometimes you can use a name to if all of the servers in there relate to each other, like let's say they're all SQL servers, so you can do VMDK underscore SQL1. But typically, for the smaller ones, we typically use VMDK underscore just 1, 2, and 3. So I'll get to that in a moment. But just to finish off over here, if I go to my Windows Explorer and I look at my iDrive, I now have my iDrive showing up here, just like all the other volumes, and it's there for me to do whatever I want. I can create a new text document, save it, just like any other volume, and then all of this is saved on the SAN, okay. And if I look at my favorite targets, I'll see here that test one was added. And one other last thing to do, which is quite important also, is if you go to volumes and devices, click on auto configure. And what that'll do is, you notice I put an I in there. That helps also with telling Windows upon boot up to expect the iSCSI drive to be the I drive. And this will guarantee that the drive letter doesn't get changed during the boot up process. And that's pretty much it. So on our targets, we see we're connected, and our favorite targets, it's listed as well, so that next time it boots, and that's it. At that point, we're done with this volume. Create OK. So now what I'm going to do now is I'm going to clean up what I just did. So if we want to take apart a volume and remove a volume, I can go back to the iSCSI initiator. So first things first. First thing is you have to make sure you close all windows accessing the data. And then what I like to do is I like to go here, okay, and right click on the volume and choose offline. The reason why you should do this is because if you don't make it offline, there might still be some connections to the volume and it might not let you disconnect it in iSCSI.
Can you just delete it, or?
Well, I can delete the partition. Yeah, I can delete the partition if I want, but
You
that's
don't have
still, I don't have to, right? Because in this case, I'm just going to take care of it from the SAN. So it's best to first make the volume offline again, okay? And then I'm going to go back into my iSCSI initiator, start administrative tools, iSCSI initiator, okay? And then I'm going to highlight my volume and I'm going to choose disconnect. And watch, look at the bottom of the screen, you'll see as soon as I hit disconnect, it'll say, it's just confirming, I'll say yes, boom, gone. Second I hit yes, it's gone. Okay, and in this case I want to make sure, because I'm deleting this volume, I want to make sure I get rid of it so I don't get any boot up errors. I'm going to remove it also. It's not really going to, it'll only show in the system event, it'll say can't find iSCSI volume. You told me I have a volume in the favorite targets for test one and I can't connect to it. So in order to prevent that, it's always a good idea to just remove it from here as well. Okay, and then at this point, if I go back to my CMC, you'll see my test one, when there is an active connection, you'll see, you notice how there's like a open to parenthesis next to each one of these volumes. That means that there's an active iSCSI session. But my test one, because I just disconnected it, I'm gonna go back and connect it actually just to show you this illustration. If I go back here and I choose connect, I'm gonna add it. Okay. So now you'll notice that now there's an open parentheses over here next to the. Do you see what I'm talking about?
Again, you didn't put anything on it. It just connected.
It just means it's connected, exactly. But once I go in and then I disconnect, you're going to see that open parenthesis disappear, watch. Just highlight the volume, choose disconnect, say yes, disappear. So that's how you'd see at a glance from the CMC whether or not a particular volume is actually connected to a server or not. Okay, and now at this point I can go in here, let's say I want to get rid of my volume, I can right click, choose delete. Always be very careful when you're deleting, you're playing on SAN, because one wrong move will will be extremely detrimental.
How do you restore if something like that happens?
That's why we have something called VDR, a diverse set of backups that are outside of the SAN. So, and you get a nice big warning: deleting volume test one will permanently delete all of the data on it. This is irrecoverable if you delete it from here. So if I choose delete.
And on a VDR level, you just back up the data from the volume, so you have to recreate it.
VDR actually backs up the entire server, with the data.
Including the HP
yeah, exactly,
volume?
Exactly. Because a BDR is able to, BDR just cares about seeing drive letters, that's all it cares about. So even if the drive letters, are representing a nice iSCSI, volume that's residing on a SAN, it doesn't care. As long as I can access it via a drive letter, it will grab that data, and it will back up that data, because all it is just a regular NTFS volume.
Well, I'm talking BDR does not back up the cluster configuration.
No,
If
no,
you
no,
deleted the
absolutely,
volume, you have to
correct.
recreate it and
Correct,
manually store it.
correct, exactly, yes, that's correct. The BDR just backs up, Windows
Is that
servers
back up to
and
this
Windows
cluster?
data.
Like built
No.
into the.
No, the SAN IQ does not interface with any other company or any other technology.
It doesn't have its own backup.
Well, the redundancy is in the fact that you have multiple nodes.
No, but I mean against user error. Like you deleted the volume, you have to remember what it was. You don't have a way to export and import stuff to look at.
That's correct. That's why you have to be very. So that's one of the things we do with our SAN planning worksheet. And there's actually another tab on the SAN planning worksheet for listing volumes, which allows you to.
Also rewrite all
Also-
that down.
Yeah, exactly. So that's part of why we try to use that in conjunction with, proper naming conventions, so that when we look at the screen over here, we know exactly what's going on. We know which volume is connecting to which server. We know what drive letter it is. We know what the purpose of that volume is. So we don't make any mistakes when trying to administrate it and doing correct things.
Just another
Yeah,
question, going back to the thin provisioning though.
Yes.
So, can we run into a situation where we've
Over provision.
overprovisioned?
Exactly, and that's something I wanted to mention. Thin provisioning is a double-edged sword. On the one hand, you have the ability to dynamically allocate as needed storage, but on the other hand, you also have the ability to over-provision your storage, and it's not such a bad thing to over-provision your storage. In fact, I would say 100% of all of our deployments are all over-provisioned, but you just have to make sure that you keep a tab on the utilization, which we do by using email alerts, which is something we'll show you later in configuring email alerts. But basically, when a cluster starts getting low on space towards 90%, it will generate an email alert that I'm at 90%, just letting you know, and you better do something, or else if you continue, you will fill up the SAN. Actually, one nice graph is if you click on the cluster and then you click on this, the use summary tab. This is a very nice graph that actually shows you the provision is how much data I'm actually using. Okay, actual data, not meaning not in other words that volume that I had that was 10 gigs. If I didn't fill up that 10 gigs, it wouldn't show up here. This is actual data from the SAN that actual volumes that have data on it. So the SAN is using 8.3 terabytes. I have 3 terabytes free available, okay? The total of my entire SAN is 11.3 terabytes. And look how much I provisioned. I'm way over provisioned. Well, not way, but significantly provisioned. I provisioned 15.76 terabytes, of volume space. Now, that, like I said, that's actually not a bad thing, because it allows me to not dedicate storage that can never be used for another volume. Again.
But if it's easy to extend volumes, you might as well provision what you have.
But if you make a volume full, that space can't be used. That space will, put it this way, if I made all of these full, this free space would disappear immediately. This free space would and in fact I wouldn't be able, if I start making all these volumes full, as soon as I do it for each one of these volumes, this free space will disappear, and then I'll get to a point where I've used up all my free space, and now I can't make the rest of these volumes full because I cannot if I have everything as full, I can't over provision. I'm only carving out exact amounts of storage for every single volume, regardless of what data is inside that volume and whether or not that space is being used or not.
But the reason to do it is because you don't know which actual volume will grow in the future, and you want to allow them to...
Exactly, precisely. That's the reason why we do it, because we don't know which volume is going to grow in the future, and we want to be able to maintain as much free space, available space, to allocate to volumes as needed. So if my Exchange database has to grow, I have the data, I have the free space available to allocate to it. If my file server needs are growing because we added about 20 designers and they need the free space, then I have that space now to add to that. And it allows me to properly plan, my capacity and dynamically allocate as an as-needed basis. And then, but we have to make sure, obviously, that we keep tabs on storage usage and, make sure we take action when things start getting low, either by deleting volumes if needed, or converting them to RAID 5, archiving data, or adding a new node. So that's the big benefits of ThinBridge. That was the question, right? Okay. So that takes care of connecting. Now, basically, even though I connected now from a physical server, it's the same idea when connecting from a virtual server. Basically, if I go to my list of NICs on the server, which is, you can see the same thing on a virtual, right? Any server that's going to connect to a iSCSI has to have a secondary NIC for that network. So if I click on properties and I look at actually not because
And you can have multiple NICs.
well, yeah, no, the reason is because I have Hyper-V. Hyper-V takes over your physical NIC. So you'll see that I have here my IP address for my other NIC. So you're going to have that same NIC whether you're dealing on a virtual or a physical.
And for multipathing, you have to do something special?
So the multipathing is a whole separate. We're going to get to that. We're going to have to get to that soon. So yeah. So the next thing is really is the next topic to discuss, which probably should be the final topic, is the vSphere client connecting from vSphere client. Maybe we should take a break now. I think it's a good idea to take a break now, and then get back to doing this afterwards. So maybe we'll stop the camera. Okay, so the second thing we need to cover is connections to SAN volumes via ESXi. So let's show an example of how to do that. I'm going to create a new volume on Excelco's SAN. We're going to call it VMDK_test. This kind of follow the proper naming convention. Just one. Okay. And I'll make it 10 gigs. Okay. And during volume creation, I have the ability to assign the volume directly right here. So if
Assigned
to the host.
Oh, to the host.
Yeah. So in other words, just like we have server connections for Windows machines, we also have server connections for ESXi hosts as well. And I'll show you where to
Don't
get
they
the.
all get connection?
But yes, each host has to connect. Each host has to have a separate connection to the CMC to allow you to assign and unassigned volumes to. And data store volumes, we always assign them to every host because that's part of the magic of having a SAN in the fact that we're able to have shared we have shared storage amongst all of the hosts and allow us to move VMs between hosts when needed. So in this case, this is Excelco. They have a 2-node vSAN, similar to what you're setting up now. So I am going to assign this test volume to both VS1 and VS2, which are 2 hosts. Okay, I'm going to click OK. Now it's giving me a warning that you're in the process of assigning more than one server to a volume, which could result in data corruption. So it's letting you know that make sure you're using a clustered file system before you continue.
Well,
so
IPSXi.
exactly, like ESXi, which uses VMFS, which is a cluster-aware file system. So we don't have to worry about that. We'll click continue, and we'll go to the advanced tab. We'll keep two-way mirroring. That's the only choice we have really. We're not doing RAID 0, but we will change the provisioning to thin. Okay, because we typically do that on all volumes. And then we click OK. All right. So now at this point, I have my I have my volume down here, VMDK test 1, and it's assigned to both VS1 and VS2. So if I go to my vCenter where I can see both of my hosts, okay, right now I'm on VS2 over here. In order for me to connect, what I have to do is, if I click on storage adapters, okay, so under the configuration tab in storage adapters, we see the iSCSI software adapter listed over here. Now, by default, when you first turn on ESXi host, you're not going to see it listed at all. All you'll see is just the whatever smart array, whatever controller's under. You won't even see the iSCSI software adapter listed. In order to get it to list, you have to click on add. Right now it's grayed out because it's already added on this host. But if you see on the top right, you click on add, there's only one option to add, the iSCSI software adapter. So when you click OK on that, it will then add that software adapter to appear here. And then at this point, you can click on properties over here. And then for one of the first things you'll see is the familiar thing we saw on the Windows iSCSI initiator, which is initiator name. It's a similar looking name. So when we originally set up the server connection over here, you'll see, if I go to properties of the server connection, this name matches the name over here.
Where does it originally come from?
Yes, this is where it originally comes from. When you click on add and you add the iSCSI initiator, it will create the name here and give you the ability to go to the properties to be able to set the IP, which is what I'm going to show you next. If you go to dynamic discovery, okay, here is where we add the IP address of the VIP cluster IP. Same thing like we did in Windows. It's the same thing you're going to do over here. And basically we just hit add, okay, and then at that point, what I do is I click close. So when you first add the IP, it's going to tell you that you need to rescan the host bus to detect any new LUNs. Alternatively, you can always click on rescan all on the top right, and that will initiate a scan for new storage devices. So if I click on OK, so just so you notice, you see right now this server has 6 devices, right, listed in 12 paths. So this will change once it detects and sees. Takes a moment to scan. You see in the bottom in progress. It takes a moment, and now it's just incremented to 7 devices. So that's our new volume that we just added. But all we did right now is just create a iSCSI connection to the volume. The next step at this point is actually creating a data store based on that volume. So if I move back to my storage section over here. Okay.
Each volume has their own separate connection.
Exactly. Each volume has its own separate connection. And it's actually 2 connections with multipathing. I don't want to get to multipathing right now, just going to keep things simple. Right now we have a list here of all of our volumes that are connected via left hand. Okay, and now I want to add our new volume. So in order to do that, we click on Add Storage on the top right, and it will bring us to the Add Storage wizard. Okay, so we're always going to select the first setting, which is where we're adding an actual LUN through iSCSI. Click Next. Usually it'll detect right away that you've got a new volume. Okay, and as you can see here, we have a new left-hand iSCSI disk that hasn't been configured yet. It's 10 gigs. Okay, so that's the one I'm going to select. Okay, then I'm going to click on Next. Okay, telling me a partition will be created and used. That's great. Click Next. Enter a data store name. So typically we enter the same name that we do in the left-hand console. So it's going to be VMDK underscore test1, but we'll append to it an underscore ds for data store. So as you see, all of these have an appendation of underscore ds.
Mm-hmm.
So we're going to do that on this one as well. I think it's called it test1. So you have to be careful with these volume names again because volume names in the ESXi could be changed. Volume names on the CMC cannot be changed. Cluster names cannot be changed. Management groups cannot be changed. So that's why it's very important to make sure that it's done perfectly correct before proceeding. And in this case, we want to format the maximum capacity of of the volume, which is in our case 10 gigs. Click next, click finish. Okay, we wait, doesn't take long. You see on the bottom here, it's creating VMFS data store, and boom, there it is. It just appeared on the list like that. So now I have my new data store. If I browse it, it's going to be empty right now, but assuming I have this data store large enough, you know, to put in a VM or whatnot, I have the ability to put VMs in here, you know, whatever else I need to put in. So now this only shows the LUN right now on VS2 because I have VS2 highlighted over here. If I switch to VS1 and I go to configuration and I go to storage, I don't see my LUN here yet. So the way I'm going to see it is very simple. I'm going to hit rescan all, because if you remember, the LUN was presented to both VS1 and VS2. So what will happen now is two things will happen. It will scan, as this screen will show, it will scan for new storage devices. Okay, it'll find the path to the iSCSI drive, and then in addition to that, it's going to scan for any new VMFS volumes. So since I created the volume in VS2, it's going to see that there's a new volume that exists, and it'll automatically add it to the list. So I click OK.
If you have 10 hosts, you have to scan all 10, or you can do it somehow.
You gotta do each one. Yeah, you gotta do each one. And boom, now it shows up. So now I have this exact data store that's being shared or accessible from both hosts. And now they'll both show the exact same thing. If I start filling this one up, right, the free space will go down. As soon as I go into VS2, I'll see the free space down here as well. Sometimes you may have to hit refresh. You might not show it right away. If you hit refresh over here, that's the same thing like in Windows, refresh. It will update the free space and show you exactly what the status is.
There's an empty volume for now.
Right? Yeah, exactly. Right now, it's just a test empty volume that I created.
Which we can use to put VMs in or anything.
Yeah, well, yeah. I mean, it's quite small now. You can't really fit it in
Right.
a VM. Even a Windows 2000 machine, I don't think you could fit on there.
Right.
Yeah, basically, when you make one of the proper capacity, yeah, the purpose would be to provision VMs in there,
Okay.
yeah, and be able to group VMs appropriately, which is something that there's something else on the SAN spreadsheet. If you look over here, there's another. This actually is not on the printed list, but I put in another tab here called SAN volumes. The purpose of this this sheet is for you to list all the different drives that you plan on putting, with their total size and an estimate of how much of the data store will be allocated. So this has an estimate, for example, the C drive. This is back in the day. This is an older sheet, but this is back in the day when we were installing 2003. So typically we created C drives of 50 gigs back in those days. So data store allocation, so when you install the C drive, how much is Windows going to take up with an initial install together with the amount of updates that you put in, approximately 25. So basically these three columns over here, you notice that there's a formula, SUMIF, SUMIF, SUMIF. What this formula does here, it adds up everything that is listed under VMDK1_DS. This one adds whatever is under VMDK2, and this one adds whatever is under VMDK3DS. And the purpose of this is to estimate how big of a data store you should create to begin with. Because what's important to know about data stores is those you cannot shrink no matter what. There is no way to shrink a data store once you size it. So it's extremely important always to be stingy and cheap with sizing, because you can always go up, you can never go down. The only way out is to migrate out off of there, assuming you have enough space to migrate off of there. That's why you have to be extremely careful in making sure not to make data stores unnecessarily big, because that space can never be recouped. Unless you migrate all machines off of there and then delete the original data store. then you can recoup the space back on the SAN. So purpose of this sheet is that if you plan on doing a major overhaul of the network, you're doing a lot of P2Ving, you're doing a lot of new servers, and you're trying to figure out how many data stores you need, and how large of a data store you should set them to. This particular sheet can help you get to that answer, because like I said, it adds up the BS allocations of every single one of these volumes. The ones that are only on data stores, not this, because this is a dedicated volume, but the ones that are 1, 2, and 3, it'll show you how big those data stores should be in order to make sure you have everything. You'll fit everything. So when you go to create your data stores in the CMC, you'll know what number to put in here for VMDK1. You'll know how to make it 200 gigs, 250 gigs, 300 gigs, depending on how large of a network you're doing. Okay, so I mean that really concludes volumes and connecting to them via Windows and ESXi. If you want, I'll spend a few more minutes just to talk about snapshots. Snapshots, basically, the concept is that what it allows you to do is when normally the volumes are written to directly. All writes and reads occur on the volume itself. If you take a snapshot, what that does is that pauses writes momentarily, creates a new file, and then all reads and writes now happen basically on the new file, and then that file allows you to it keeps track of all the changes from when you did the snapshot, so that if you ever have to revert a volume back to a previous state, when you hit revert volume, it will look at that snapshot and backtrack all the write changes to the original time when the snapshot was taken.
This is you talking VMware
or
left hand?
So this is left hand. It's a similar concept with VMware as well, but in particularly with VM with the HP left hand, it works on an entire volume, not just a virtual machine. So for example, if you have data volumes like FS1 data over here, right? Let's say this data volume gets encrypted with CryptoLocker, which has happened and something that Jeff has worked on numerous times. So typically we configure snapshot schedules to snapshot, let's say once every day or at night, and then you're able to. And if I could show, actually, we don't have anything configured on this one, but GNA could be GNA. Yes, GNA does have a couple of snapshot schedules here. So if we look at these schedules, we see that it's a pretty simple schedule. It runs nightly. Okay, this one runs at 7 p.m. every night, occurs every day. Okay, and then it retains 2 snapshots. So the issue is that if there's a high rate of change, you don't want to retain too many snapshots because then you'll eat up a lot of space on the SAN very quick. So they were actually very low on space. Could be we had maybe 4 or 5 snapshot retention originally, but they got very low in space, so we had to lower it to 2. Could be now at this point we put in new nodes, so we can go in here and actually increase this so that they can have a little bit more of a snapshot retention. But that's also something else to do when you're troubleshooting space issues. You can lower retentions on snapshot schedules so that snapshots can get deleted, and it's right away. If I change this to 1 right now and click OK, it will immediately delete 1 snapshot.
And so you delete the snapshot, it's merged into the main.
Exactly. It merges it into the main. It merges all the changes into the main one. Correct. So that's how this works with setting schedules on snapshots. You could also anytime create a manual snapshot. If I just want to be safe, or if I know I'm doing something and I'm not sure if it'll affect the data, I can always just right-click any snapshot, any volume and say new snapshot, and then just click OK. It will take a snapshot. There's also a concept of, as you see over here, application managed snapshot. So typically when you take a snapshot of a volume, it's going to do it on the SAN level without communicating at all with the underlying server. So if you're just doing a file server, it's not really much of a big deal. But if you're talking about databases, it's the equivalent of basically taking a crash consistent backup. And typically the issue is with Exchange and SQL databases, usually those are separated into two different volumes. You have your log on one volume and your database on another volume. So the issue is you can't really physically take a snapshot at the exact same time of both of them. Even if you set your schedule to be 7 p.m. on the dot, there's always going to be a minute difference between the snapshot of the database volume and the log volume, and there's a good chance you're not going to have the two in sync, so that if you ever needed to revert back to that snapshot, you could potentially corrupt your database. So there's this concept of application managed snapshot, which there is a plugin to install on a Windows machine that works for SQL. It works for Exchange. And it even works for vCenter, which I'll get to in a minute. But the simpler way to understand this with SQL and Exchange is that when you have that plugin installed and you take an application managed snapshot, the SAN will communicate with the application manager on the server, and it will tell it to quiesce the database, take a VSS snapshot of the database, so that this snapshot will be a very clean, copy of the database, with the database is properly quiesced. And vCenter also. vCenter relies on. This will work really on VMDK volumes that just have C drives. You're able to communicate with the vCenter server, and it will actually take a VMware snapshot behind the scenes before it takes the SAN snapshot. Then it will take the SAN snapshot, and then it will unmount the VMware snapshot and get rid of it. So that basically you have a clean copy of your VMware machine that was properly quiesced from the operating system state, because VMware does it via VMware tools. So
that has to be configured, or it's automatic?
No, it has to be configured. And that's if you remember when I went over here, there's a field, a controlling server IP address. So this is where you would put actually the IP address of the vCenter server if you were actually taking vCenter snapshots. Yeah. I played around with the feature when it first came out. It was very buggy initially, and we're not a big fan of VMware snapshots due to the fact that they fail a lot, and they have issues where they leave residual snapshots in the data store, and that causes problems whenever you're trying to, let's say you wanna enlarge a drive. You're not able to enlarge the drive if there's orphan snapshots. Orphan snapshots also cause a lot of performance issues. Even VMware themselves say make sure you don't have too many snapshots, because the more snapshots you have, the more performance suffers. So therefore, we typically haven't been using the vCenter version of the application managed snapshot utility. But so basically, so the thing is, with each of these snapshots, if you ever want to access data, there's actually two ways to access the data. You can access it via a plugin that. Huh? Not even 5 minutes. Yeah. Okay. You can actually take any one of these snapshots. If I right click, I can choose assign and unassign, and I can assign this to any one of my servers just like a regular volume. At that point, I can go and through my iSCSI initiator, whether in Windows or in ESXi, depends what kind of volume it is, I'm able to actually mount that snapshot and view the data and be able to copy out in Windows or through the data store browser in ESXi. I can copy out whatever files I need from that snapshot if need be. There's also a plugin from HP that actually allows you to install it on a Windows machine like on a management server, and it can also directly access data from the snapshot without having to mount it in the CMC. It's a little wiggy. I don't like it so much. Personally, I like to do it the old-fashioned way of just mounting it and grabbing the data that way. The other one, it sometimes hiccups and causes issues. And then the last thing to know about something that you've done many times is a volume rollback. If I know for a fact that the current volume, let's say, has corruption or encrypted files, and I know that I have a snapshot that goes back to a date, a time that has data that was before the corruption occurred, I can simply right-click any snapshot and choose rollback volume. Very dangerous.
And you lose whatever you did.
Exactly. Now it's very important before doing that to make sure you disconnect any iSCSI sessions. So that there's no changes being written to the volume at the time you're doing the rollback. And the rollback actually happens very quickly. It's not like you have to wait too long. The rollback happens very quickly. Usually you click OK, it says rollback completed, you click OK. Then at that point you reconnect your iSCSI connection, and you'll see the changes, and you'll see the data as of when that date of the snapshot that you took. So that works very great. We've used it many times. It saved us many times. That's why snapshot schedules are extremely important with file server data, because it's a lifesaver for being able to restore an entire volume that's been encrypted very quick, much quicker than doing a restore from, let's say, a BDR, which would require copying the data on a file basis. This is literally a block level restore of the entire volume, more or less at the snap of the finger. So it's definitely something that's saved us.
And the size of the snapshot is the same size of the drive, or is it?
So no, the size of the snapshot is typically the size of the rate of change of data. It's interesting you bring that up, because the CMC used to actually give you that information in the older versions. It confused so many people that they took it out. Now we have no visibility in how large the snapshots are. So we just know they exist, and that's pretty much it. And we can assign and unassign and roll back if needed. Okay, any questions?
So snapshots, you keep all the data volumes, but not the operating system volumes?
So we could take snapshots of operating system volumes. The issue with that is you're typically not going to roll back an operating system volume, because usually there's more than one VM in there. We don't want to roll back all the VMs. However, you could mount a snapshot of a VMDK volume in VMware, and then let's say copy out a VMDK file.
Oh, I see.
So that's one thing you're able to do, or a VMX file if that gets corrupted. So it does have its benefits that way. So rollbacks are not going to happen typically unless there's only one VM there. If there's just one VM, but typically we group. There's no reason. If we would put one VM in every SAN volume, you would have a volume for every single server, and this list would be extremely large. So there's no reason not to. And HV says is you shouldn't put too many on one volume. Say the average would be anywhere between, the max would be like 8 to 10. You shouldn't have more than 8 to 10 VMs per volume. Even you don't even have to get that high, 5, 6, 7. You can start spreading the load a little bit amongst multiple volumes. That's it, I think.
Thank you.
All right, any questions? Okay.
Questions will come when we start working.
Yeah. Okay. Of course, was useful.